Antarctica is the last place on Earth that still keeps secrets. No cities, no roads, no permanent residents, just 3.5 million cubic miles of ice, sitting on top of a continent that almost nobody has ever actually seen. Because here's the thing most people don't realize. We have never looked at the real Antarctica. Not the rock, not the mountains, not the valleys. For decades, everything we thought we knew about this continent was based on what's on top of the ice, not what's underneath it. And in the year 1996, that changed forever. Using ice-penetrating radar, a team of Russian and British scientists detected something almost 2.5 miles beneath the frozen surface, near a research station called Vostok. A massive liquid lake, not frozen, not solid, liquid water, sealed away from sunlight, from our atmosphere, from the rest of the planet, for millions of years. That discovery didn't just add a lake to the map. It opened a door into a hidden world, a world of buried mountain ranges, ancient microbial life, and a climate record that reads like a warning label for the next century. And what scientists have pulled out from underneath the ice since then is stranger, older, and more consequential than almost anyone expected. Let's go underneath. Lake Vostok sits beneath 4 kilometers of solid ice. That's ice so thick, if you stood it on end in Manhattan, it would tower well above most skyscrapers. At that depth, the pressure is immense. Sunlight has never touched the water, and the temperature of the ice above can plunge past minus 80 degrees Celsius. In fact, the coldest natural temperature ever recorded on Earth, minus 89.2 degrees Celsius, was measured right here near Vostok Station in 1983. But Vostok isn't alone down there. Since its discovery, scientists have mapped out more than 400 subglacial lakes hidden across Antarctica. Some are small, shallow pockets of water. Others, like Vostok, are enormous, roughly the size of Lake Ontario, and unimaginably old. These lakes exist because of a strange balance. The ice above is so thick and so heavy that it insulates the ground beneath it, trapping geothermal heat from the Earth's crust. That heat, combined with immense pressure, keeps the water at the base from freezing, even in a place otherwise cold enough to kill a human being in minutes. Which means these lakes have been sealed off, completely isolated from our atmosphere, our sunlight, our weather, for an estimated 15 to 25 million years. 15 million years of complete isolation. For context, that's before humans existed, before most of the animals we recognize today evolved. An entire ecosystem cut off in total darkness for longer than our species has a name. So naturally, scientists asked the only question that mattered. Could anything be alive down there? For a long time, the answer seemed obvious. No. No sunlight means no photosynthesis. No photosynthesis means no food chain. Crushing pressure, near freezing temperatures, absolute darkness. This should be a dead zone. Then, in January 2013, a research team called WISARD, the Willans Ice Stream Subglacial Access Research Drilling Project, drilled through 800 meters of Antarctic ice to reach a smaller, shallower body of water called Subglacial Lake Willans. What they pulled up in their water samples should not have been there. Microbial life, thriving, nearly 4,000 distinct species of bacteria and other microorganisms living in total darkness, cut off from the sun for who knows how long. These organisms don't survive by photosynthesis. They survive through a process called chemosynthesis, pulling energy not from sunlight but from chemical reactions with minerals in the rock and sediment beneath the ice. Iron, sulfur, ammonium, an entire food web built on chemistry instead of light. It's one of the most extreme forms of life ever confirmed on Earth, and it raises an unsettling question that astrobiologists have been chasing ever since. If life can survive in an ice-sealed lake here on Earth, in the dark, under crushing pressure, cut off from the sun for millions of years, where else in our solar system might we find something just like it? Because we already know there are ice-covered oceans like this on other worlds. But before we go looking at other planets, there's something else buried beneath Antarctica that scientists are still struggling to explain. Something that shouldn't exist where it exists. A mountain range as tall and as rugged as the Alps, completely invisible, completely hidden, completely buried under nearly 3 kilometers of ice. They're called the Gamburtsev Mountains, and scientists didn't even confirm their true shape and scale until a major radar and seismic survey called AGAP, conducted between 2007 and 2009, mapped them in detail for the first time. Peaks, valleys, jagged ridgelines, a mountain range every bit as dramatic as the ones we hike and photograph and put on postcards. Except no human eye has ever seen it. No sunlight has ever touched its peaks. It sits there in absolute darkness, exactly as it has for millions of years, completely entombed. And here's the part that genuinely puzzles geologists. Mountains like this usually form at the edges of tectonic plates, where continents collide and push rocks skyward. But the Gamburtsev Range sits in the dead center of the East Antarctic Craton, one of the oldest, most stable pieces of crust on the entire planet. There's no obvious collision, no obvious fault line driving this uplift. So how did a mountain range this large form in the middle of nowhere, and then get perfectly preserved by a natural deep freeze for millions of years, hidden from the rest of the world? Scientists still debate the exact mechanics, but what we do know is this. Antarctica is not the flat, featureless white sheet it appears to be from a satellite photo. Underneath, it's a landscape of buried peaks, hidden valleys, and frozen basins. A ghost continent layered beneath the one we can actually see. And it's that ice sitting on top of all of it. The mountains, the lakes, the microbial ecosystems, that holds the most unsettling story of all. Because ice, it turns out, remembers everything. When snow falls in Antarctica, it doesn't just disappear. Layer after layer compacts over thousands of years, trapping tiny bubbles of the ancient atmosphere inside. Drill down through that ice, and you're not just extracting frozen water. You're extracting a time capsule of Earth's climate, one layer at a time. Ice cores pulled from sites like Vostok and Dome C have given scientists a continuous climate record stretching back roughly 800,000 years. Every ice age, every warm period, every shift in atmospheric carbon dioxide, locked into the ice like pages in a book and readable today, sample by sample. And what that book tells us is deeply uncomfortable. Current atmospheric carbon dioxide levels are higher than at any point captured in these ice core records. Higher than anything the ice has recorded in the past 800,000 years. Not close, not comparable, unprecedented. But the ice isn't just a record of the past. It's also a warning about what's coming. Which brings us to Thwaites Glacier, a slab of ice roughly the size of the state of Florida, sitting on the western edge of the continent. Scientists have nicknamed it the Doomsday Glacier, and not for dramatic effect. It's earned the name. Thwaites is melting from below, where warm ocean water is eating away at the ice shelf that holds it in place. And Thwaites alone, if it were to fully collapse, holds enough ice to raise global sea levels by roughly 65 centimeters, or about 25 inches. But here's the truly frightening part. Thwaites isn't just melting on its own. It acts like a cork, holding back a much larger portion of the West Antarctic ice sheet behind it. If that cork fails, glaciologists warn it could destabilize enough surrounding ice to eventually contribute to several feet of sea level rise over the coming centuries, reshaping coastlines that are home to hundreds of millions of people today. And in recent years, researchers using underwater robots have documented cracks and fractures spreading across the underside of Thwaites' ice shelf. A slow, grinding process that satellite data suggests is accelerating. But melting ice isn't the only warning Antarctica has revealed. In some of the strangest discoveries of all, scientists drilling into ancient sediment layers beneath the ice have found fossilized pollen, spores, and root systems. Clear evidence that Antarctica wasn't always a frozen wasteland. Millions of years ago, during warmer periods in Earth's deep past, parts of this continent were covered in moss, ferns, and low forest. A green Antarctica, thriving in a climate radically different from today's. It's proof that this landscape has transformed before under natural climate shifts over millions of years. But it's also a preview, a glimpse of just how dramatically this environment can change when the planet's temperature shifts, whether from natural cycles or something else entirely. And then there's the detail that first made people outside the science world pay attention to Antarctica's hidden mysteries. At Taylor Glacier in the McMurdo Dry Valleys, a strange rust-colored liquid periodically seeps out from a crack in the ice and stains the surrounding snow a deep, unsettling red. Early explorers who found it in 1911 assumed it was caused by algae. They named it blood falls. The real explanation took nearly a century to fully confirm. Trapped beneath Taylor Glacier is an ancient, super salty lake, sealed off for possibly more than 1 million years, rich in dissolved iron. When that iron-laced water is finally exposed to oxygen at the surface, it rusts almost instantly, staining the ice a deep blood red. And remarkably, that trapped lake isn't lifeless either. Researchers have found microbial communities surviving inside it, metabolizing sulfur and iron compounds in a place with essentially no oxygen and no sunlight. Another isolated pocket of life, quietly persisting in the dark, exactly like the microbes found beneath Lake Whillans. So what does all of this actually mean? It means the ground beneath Antarctica's ice isn't empty. It's a hidden world of buried mountain ranges, ancient lakes, and life forms that have been thriving in total isolation for millions of years, completely unknown to us until we finally had the technology to look. It means the ice above that hidden world is a climate archive, one that's already told us in unmistakable detail that what's happening to our atmosphere right now has no precedent in the past 800,000 years. And it means glaciers like Thwaites aren't just distant, abstract concerns. They're actively changing right now in ways that will directly shape coastlines and communities within our lifetimes and our children's lifetimes. Antarctica isn't a blank frozen void at the bottom of the world map. It's one of the last true frontiers left on this planet, and every expedition that drills a little deeper or scans a little further beneath the ice seems to uncover something we didn't expect. A lake sealed for 25 million years, a mountain range no one has ever laid eyes on, microbes thriving in total darkness, a climate record with a warning written into every single layer. We've mapped the surface of Mars in more detail than we've mapped what lies beneath our own southernmost continent. Which raises the only question that really matters as our instruments get sharper and our ice cores get deeper. What else is still down there waiting to be found, and what might it end up telling us about where we're headed next?